हाँ जी, I'm audible. So to last class, we have finished diffraction. There is just one last topic left, and that was the intensity distribution curve. When we draw the intensity distribution curve, we did this thing in the last class or not? This intensity distribution curve?
We did, sir.
Yes, we did this in the last class, no? This intensity distribution curve for diffraction.
Yes, sir, we did.
Okay, we did this thing. Fine. So diffraction is over. After diffraction, ray wave optics is over. The next topic is ray optics. So let's start with the ray optics. See, what's the basic difference between wave optics and ray optics? When we study wave optics, we consider light as a wave. But in ray optics, we consider light as a geometrical object. In ray optics, we consider light as a geometrical object. A geometrical object that you must have studied in your early geometry classes, class 6, class 7. And geometry, in Euclidean geometry, there was a concept of one geometrical object, which is known as a ray. Ray have many properties like a ray travel in a straight line. Two parallel rays will meet at infinity. If you have two parallel rays, then you will have alternate angles. You will have corresponding angles, vertically opposite angle. So all those geometrical properties which were valid for a ray in geometry are valid for light also. So in ray optics, we consider light as a geometrical object. It's a ray of. So just like the ray of geometry, the ray of optics will travel in a straight line. Two parallel rays will meet at infinity. If you have transversal, then you can compare the alternate angles. You can compare the corresponding angles. So here in ray optics, your light is a geometrical object. So in geometrical optics, we have four topics: reflection, diffraction, dispersion, and optical instrument. So last year, reflection was a part of deleted syllabus, but recently they have included reflection in the syllabus. But reflection is a very introductory part of reflection, syllabus. The major chunk is refraction. So we can start from reflection or we can start from refraction. So we'll start with refraction and then we will do dispersion of optical instruments and in the end we will do reflection. And this ray optics is the last major chapter of the syllabus. After ray optics, we have modern physics. Each chapter will not take more than one lecture. So after ray optics, I start assuming that syllabus is over. You should start your review. Okay, so when we start ray optics with certain characteristic of ray. That ray travels in a straight line, which is known as like linear propagation of light. That light rays always travels in a straight line. The second thing is principle of reversibility of light, which means if light is traveling in this direction, and you put something like mirror here, then light will retrace its path. If light rays are coming like this, and you change the path of light over this point, then the entire light ray will repeat its path. This is what we call principle of reversibility of light, that light will retrace its entire path. Then we have the concept of source and object. In ray optics, by source we mean an object, a source of light. Object means a source of light always. So that source may be a luminous source or a non-luminous source. If you have a bulb and you are getting light rays from a bulb, then for you, bulb is a luminous source, is an object. But instead of bulb light, say I have a pen. Light rays, pen is non-luminous, it does not have its own light source, but it do reflect the light rays. I can see this pen just because it reflects the light rays and then those light rays enter my eye and I can see this pen. It does not matter whether this pen is luminous or non-luminous. If some light rays are coming from this pen, then this pen is an object for me. So for this pen, it's not luminous. The light rays are coming from some luminous source, and after reflection from the pen, it's coming to my eye. But for my eye, the light rays are coming from this pen only. So I will say that this pen is a luminous source. It's an object form. So object simply means the source of light. Next, we can have two types of objects. One is the real object, another is the virtual object. For real objects, the light rays diverge. So if the light rays are diverging from an object, then that is a real object. It's this definition is opposite to that of image. So if light rays are diverging from something, it's a real object. If light rays are converging into something, then that is a virtual object. So here, light rays are diverging. So this is a real object, but here light rays are converging. So it's a virtual object. The next is image. For ray optics, image is a point at which rays actually meet or they appear to meet. So let's say if you have a lens, say convex lens, then after refraction from the lens, rays will actually cross each other. Rays will actually meet. So your image will be a real point. But instead of a convex lens, if you have a concave lens, then rays will get diverged. They will not actually meet, but they will appear to meet at a point. And that point is what we call the virtual image. So we have two types of images, real images and virtual images.
Sir,
Yes.
what is example of real and virtual object?
Real object is, let's say you have this pen. This pen is a real object. But instead of this pen, if I say that I have some source, from this source, light rays are passing through the concave lens. Then concave lens will diverge these rays. Now these rays are passing through some convex lens. So for this convex lens, these rays are coming from a virtual object. So if you have, let's say you have a lens, the image of that lens is a virtual image. And that image is acting as an object for another lens. For another lens, that image is a virtual object for it.
Okay, sir.
So it's always like there is no physical object which I can say this is a virtual object. It's always image of something. We know that concave lens, convex lens forms a real image, but concave lens forms a virtual image. So if the image of concave lens act as an object for any other lens, so for that other lens, the object is virtual. In short, if you want to identify whether your object is virtual or real, and just look at the rays. If the rays are coming diverging, then this is a real object. But if rays are converging, then it's a virtual object. For image, it's reverse. Image is basically the point at which rays meet or they appear to meet. So if you have rays and they converge at a real point, then you call that real point as your real image. But see, if rays are diverging, they will not meet anywhere. But if you produce these rays in the backward direction, then they appear to meet at a point, and that point is virtual image. Haji, is it clear, everyone? Akshay, Arpit, Miraj, Munib, Alia.
Yes, sir.
Yes.
Okay, so these are basic definitions. These are some really very basic definitions. Just you can note down the topics of the ray optics from here.
Excuse me, sir.
Yes, Arpit.
So the principle of reversibility is basically reflection, right?
Not reflection. If you, this principle of reversibility simply means if you change the path of light at any point, reverse the path of light, then it will retrace its path. In reflection, light may not retrace its path. If light rays comes like this, they go like this way. It's not retracing its path. Principle of reversibility means if light is going in this way, in this direction, at some point you reverse the direction. You can reverse the direction using a mirror, or you can reverse the direction using TIR or any other method. If you can reverse the direction, then the entire ray will retrace its path. In reflection, it can happen or it cannot happen. If I give this example, right? This example is reflection, but it's not reversibility. Okay, Apit?
Yes, sir. Got it.
Sir, dispersion or reflection deleted.
नहीं रिफ्लेक्शन लास्ट ईयर था, इस साल ऐड हो गया, कुछ पॉइंट्स रिफ्लेक्शन के ऐड कर दिया, but वो reflection जो add किया है वो class 10th वाला reflection. So the major topic is refraction and optical instrument. These are two major topics.
Sir, dispersion पूरे deleted.
कुछ portion हमें करना पड़ेगा. Yes, Nabil, clear this introduction?
Yes, sir.
Note down these points, please. Rectilinear propagation of light.
So can you scroll for a second?
Yes. So Nabil, you got your marks?
Sir, we were supposed to get today, sir. Today was holiday.
Because your team won the match. Huh?
Yes, sir.
Tomorrow is also holiday. Huh?
No, sir, only today.
Only today.
Done, sir.
So can you scroll?
Hmm. Can I scroll it now?
So,
Yes.
sir, in the virtual objects, sir, the rays like they appear to meet, right? They are not actually meeting.
They are yes. They in which object or image?
Objects, sir.
Object they would have met if there is no lens or mirror in between. It means if you have this lens and rays are coming in this way, these are converging rays, right?
Yes, sir.
If this lens does not refract, then they will definitely meet over this point. Then they converge over this point, and this will be your virtual object. But this lens will further refract these rays. Huh? Due to refraction, they will meet at some other point. This will be the image. If there is no lens, then they will definitely converge over this point. Virtual. Virtual object doesn't mean they don't meet. Virtual object simply means that rays are coming from somewhere and they are converging. This is the definition for virtual image. In image, rays will not. Can you scroll it now? Haji, Akshay, Minashi, Hishma, written?
Yes, sir.
All right. So these were the basic definitions for ray optics, and these definitions are valid for all reflection, refraction, dispersion, optical instrument everywhere. Now let's start with the first chapter, refraction. Before starting refraction, you should know about the optical density of the medium. See, the refraction depends upon the optical density of the medium. The optical density, so unlike mass density, optical density, mass density, mass density is mass divided by volume. Here, we are not talking about the mass density. We are talking about the optical density. So the medium which have higher optical density will have lesser speed of light. So light travels faster in rarer medium than the denser medium. So the optical density of a medium is defined by refractive index. Next, so it defines the optical density of medium. You can define refractive index into two parts. It could be absolute or it could be relative. When we say that refractive index is absolute, absolute means refractive index of a medium with respect to vacuum or free space. So if I ask you to calculate the refractive index of water with respect to air, air is free space, that is absolute. If I ask you to calculate the refractive index of glass with respect to air or with vacuum, it's free space, it's absolute refractive index. So, but if I asked you to calculate the refractive index of, let's say, glass with respect to water, or water with respect to some other gas, then that is relative. So with respect to water is absolute, with respect to other medium is relative. So if you want to calculate the absolute refractive index is simply the ratio of speeds. Say you want to calculate the refractive index of glass. So what you will do, you will calculate the speed of light in glass. We know that speed of light in vacuum, right? Speed of light in vacuum is 3 into 10 raised to the power 8 meter per second. This is the speed of light in vacuum. So if you want to calculate the refractive index of glass, calculate the speed of light in glass, then take the ratio of speed of light in vacuum and the speed of light in glass. That ratio of speed will give the absolute refractive.
Sir,
Yes,
so did you start the new chapter right now?
yes, started the new chapter. You are again late by 25 minutes.
Sir, I was outside right now. I just came right now back to home.
So just have started refraction. So this is the definition. Refractive index is speed of light in vacuum divided by speed of light. Just like speed of light, the wavelength of light also depends upon medium. So if you have a light, if it is traveling through air, its wavelength is something else. But when the same light travels through a medium, let's say glass, its wavelength will change. color will not change. Color depends upon frequency. When light change medium, its speed changes, its wavelength changes, but not frequency. Frequency does not changes, and the color of light depends upon frequency. So if you have a red light, if it travels in air, then it appears as red. If it travels in glass, it appears as red. The color will not change. Color will depend upon frequency. So refractive index, absolute refractive index is the ratio of speed of light in vacuum to the speed of light in medium. Just like the speed of light in to medium, you can take speed of light, instead of speed of light, you can take wavelength also. So you can say that refractive index is the ratio of wavelength of light in vacuum and the wavelength of light in medium. So this is the relation. If you're taking speed, then this is the relation. If you're taking wavelength, then this is the relation, lambda vacuum by lambda. So the important thing is speed of light is inversely proportional to the wavelength. Greater the wavelength, greater would be the speed of light. So Anshika, if I compare the speed of light in let's say water and glass, glass is a denser medium. The refractive index of glass is greater than water. Then each medium speed of light is large, greater, water or glass, Anshika.
Sir, it will be greater in the air.
We are comparing water and glass, not air. We're comparing water and glass. For water, refractive index is 1.33. For glass, it's 1.5. So in which medium speed of light is greater? Is it greater in water or is it greater in glass?
Water.
Water. The medium which have lower value of refractive index are rarer medium, and they will have speed of light will be greater in that particular. Okay, Anshika?
Yes, sir.
So in water, speed of light will be greater. This is absolute refractive index. Just note it down, then we'll see how to calculate the relative refractive index. Nabil, Minashi, clear?
Sir.
Yes, sir.
Arpit?
Yes, sir.
Omar, just note it down. This is the first topic, refractive index. Yeah, can I scroll it?
Yes, sir.
Tell me once you all have written to numerical based on this absolute refractive index.
So can you explain the second point?
This one?
So in the absolute refractive index, second point, ratio of speed of light in vacuum.
This is the definition of refractive index. Like the definition of speed is distance by time, right? In the same way, this is the definition of refractive index, the ratio of speed of light in vacuum divided by speed of light in medium. Like you want to calculate refractive index of glass, what you will do? You will take speed of light in vacuum, which is 3 lakh km/s, and then you will take speed of light in glass, If you take ratio of those two speeds, that ratio will be equal to refractive index. Okay, Arvind?
Yes.
Sir, what is it, sir? N is greater than 1?
The refractive index of all medium is greater than 1. The minimum refractive index is for vacuum or air, otherwise it's always greater than. Haji, can I scroll?
Yes. Sir.
Okay, do this question. See, this is a formula-based thing. This will just help you to know.
So what is that lambda?
Lambda is the wavelength. Lambda means wavelength of light.
So it can also be the wavelength of light in vacuum by wavelength of light in medium.
Yes.
Okay.
Good evening. Everyone, just please solve this question. Write your answer in chat. It's a straightforward thing. Huh? No, Nabil is wrong. Nabil is the ratio of speed of light in vacuum divided by speed of light in medium, not the other way around. Answers. A straight formula-based thing. Yes, no, it's correct. Yes, Arpit, it's correct. Anshika, correct. Akshay, Hishma, Minashi, correct. Yes, Nabil, it's correct. See, it's just the ratio. Now you take speed of light in vacuum. Umar, answer. Take speed of light in vacuum, which is 3 into 10 raised power 8 meter per second. Then speed of light in medium and just take the ratio. So V air by V medium X. So it's 1.5. Umar, clear now? You
Yes,
just
sir.
have to take the ratio of speeds. Yes, 1.5. So that is the absolute refractive index of a medium with respect to vacuum of free space. Now the next is relative refractive index. Relative refractive index means refractive index of a medium with respect to free space. What is free space? Free space means it's either vacuum. Oh, sorry, not free space. Refractive index of one medium with respect to another medium, like refractive index of glass with respect to water, or refractive index of water with respect to some diamond or something. So refractive index of one medium with respect to another is relative refractive. So if you want to calculate refractive index of medium 1 with respect to medium 2, means if you want to calculate refractive index of water with respect to glass, then what we do, we divide refractive index of medium 1 by refractive index of medium 2 now. It's N1 by N2. So N12 means refractive index of medium 1 with respect to medium 2 now. Now we have to relate this thing with speed. If you look at this expression, this one, refractive index and speeds are inversely proportional, which means refractive index of medium 1 is inversely proportional to the speed of light in medium 1, and refractive index of medium 2 is inversely proportional to the speed of light in medium 2. So if I just convert this formula in terms of speed, it's N1 by N2. In speed, this will be V2 by V1. And similarly, in wavelength, this will be lambda 2 by lambda. So this is a relative refractive index. So N12 means refractive index of first medium with respect to second medium. For example, if I asked you to calculate refractive index of water with respect to glass, Akshay, so what would which ratio will take? I'm asking you to calculate water with respect to glass. Which ratio will take? Water by glass or glass by water? Akshay,
Water by glass.
sorry.
So water to glass, right?
Yeah. Water with respect to glass means refractive index of water divided by refractive index of glass. So N12 means refractive index of medium 1 with respect to medium 2. I'm repeating again, it's N1 by N2. Now, after this N1 by N2, whatever here I'm writing from absolute refractive index. In absolute refractive index, we did this thing. Na? N is inversely proportional to speed in that medium. Refractive index is inversely proportional to speed of light in that medium. So when we write N1, inversely proportional to V1, N2 inversely proportional to V2, so E2 by V1. And speed and wavelength are directly proportional, lambda 2 by lambda. Where V1 is speed of light in medium 1, V2 is speed of light in medium 2. So you should know this relation. So this is a very interesting relation. It relates refractive indices, speed of lights, and wavelength. Next, we will add Snell's law into it, and you can relate angle, refractive index, speed, and wavelength also. Is it clear to here? Relative refractive index. If you take this example of glass and water, if I ask you to calculate refractive index of water with respect to glass, then this is simply the ratio of refractive index of water and refractive index of glass. Note it down. We'll do one numerical on it. Arpit, issues, Anshika. Aji, can I scroll it if you have written? Alia, Arpit, Ishma,
Yes.
Roha. Okay. Note this line also.
So what is it written? Refractive index of water with respect
Water with
to
respect to glass. Water with respect to glass. So water with respect to glass is refractive index of water divided by refractive index of glass. Okay, do this question. In glass, speed of light is this 2 into 10 raised power 8 meter per second. In water, it is this. You need refractive index of glass with respect to water. Do it. Okay. Akshay is the wrong answer. Oh, no, sorry, right. That's correct answer. Only correct. See, use this relation. Glass with respect to water means refractive index of glass divided by refractive index of water, which is speed in water divided by speed in glass. Arpit, wrong answer. Noha, wrong answer.
Sir, can you
Sir,
show
can
the
I see the
questions?
question?
Yes, I'm showing the question. Arpit, wrong answer. Noha, wrong answer. Alia is correct. See here, refractive index of water with respect to glass is NW by NG, which is VG by VW. I'm not asking about water with respect to glass. I'm asking about glass with respect to water. So it will be NG by NW, and here it will be VW by VG. Nabil, wrong answer. You're again taking wrong ratio. See this line. Check this line. This one. When I'm taking water with respect to glass, it's water by glass, and which is speed in glass divided by speed in water. I'm not asking water with respect to glass. I'm asking glass with respect to water. It will be reverse of this thing. Nabil, Noha, and Arpit, is it clear? Did you realize what mistake are you making? Yes, Nabil is correct, sir. Nabil is correct now. Yashika is correct. Muhammad Adil is also correct. Arpit and Noah.
Sir, I did the way you were telling, sir. But
Sorry.
sir, I did the way you were telling, sir. My method is correct, but
Your method is wrong. See, just read this line, Arpit. Minashi, you're also making mistake. Read this line. What is this? This is refractive index of,
water with respect to glass.
and how you calculate it?
For speed or for refractive index?
Both. Refractive index of water by glass, and then
Sir, then glass by water.
here what you are supposed to calculate.
Glass with respect to water.
How will you write it?
Velocity of water by velocity of glass.
What's velocity of in glass divided by velocity in water? Water by glass. Sorry. Yes, water by glass. In water, its velocity is 1.5 into.
Sir, I sent this answer only.
You sent 0.75.
Yes, sir.
You sent 0.75, na? So it won't
Yes.
be 0.75. Sorry, acha, you sent the same answer only.
Yes, sir, I sent
Oh,
the
yes.
same.
Sorry. 0.75 was the right answer. I was making mistake. Glass by water, I think.
Sir, then I
VW by
said
V.
0.75 first.
Yes. Sorry. 1.3 is the wrong one. 0.75 is the right one. Sorry.
Sir, I
Reshma.
checked thrice, sir.
Sorry. 0.75 is the right one. I remember the refractive index of water is one. Yes, Akshay, you're wrong. Ishma is wrong. Minashi was right. Anabir was right earlier. Is it clear? We're doing glass by water. So velocity in water divided by velocity in glass, 1.5 by 2. So it's 0.75. Nabil, is clear now?
Yes, sir.
Okay, you were right in the first attempt. Okay, so this is relative refractive index. Through this relative refractive index, what you can do is you can also relate the wavelengths if you want. If you know the wavelength in air, then you can relate the wavelength in water or any other medium. Okay. The next is, this is a conceptual question. Then you can ask, what are the factors on which the refractive index of a medium depends? The refractive index of a medium depends upon the nature of medium. Obviously, for different mediums, you have different refractive index. It also depends upon the wavelength of light used. Like if you take water, you pass green light from the water, the refractive index of water will be something else. You pass red light through the same water, the refractive index would be different. You pass violet light through the water, refractive index would be different. So refractive index of a medium depends which color light you are using, which depends on the wavelength of light also. And it also depends upon temperature. If you increase temperature, then refractive index will decrease. No doubt, it's an important conceptual question. Note it down. The refractive index of a medium depends upon the nature of the medium, wavelength of light used, and the temperature. If you increase temperature, then refractive index will decrease, inversely proportional to temperature. So in temperature, you can write it's inversely proportional temperature, right? Decrease with increase in temperature. Yeah, is it clear up to here?
Yes,
So
sir.
it's dramatic.
Next, we will do Snell's law. Through Snell's law, we will start the laws of refraction. Basically, through Snell's law, we'll connect angle of incidence in refraction through refractive index, speed, and wavelength.
So what is the second point?
Wavelength of light used. Wavelength of light used.
Okay.
So the refractive index of medium depends on what wavelength of light you are using.
Sir, done.
The next is refraction. So when light travels from one medium to another, its speed and wavelength change. Due to change in its speed, its path change. This phenomena is what we call refraction of light. So let me draw this diagram. So this is the phenomena of change in path of light. The cause of refraction is change in speed of light when it travels from one medium to another. So this is the boundary. This boundary is separating two mediums, medium 1 and medium 2. This is medium 1. And this is medium 2. So this is boundary separating these two mediums. And you have this incident light here. This is the normal. This angle, this is the incident ray. And this is the normal ray. So the angle between the incident ray and the normal is known as angle of incidence. So this here is angle of incidence. So when light rays travel from one medium to another, what happens is its path changes. Due to change in path, it's earlier this was the direction. Ray should travel in this direction. But due to change in medium, its path will change. Now it will travel in this direction. This change in path of light is known as refraction. This is known as refracted ray. This ray is known as the refracted. And this is the angle of refraction now. This change in path of light is known as refraction. This is angle of refraction. See, light will refract if you are not passing it through the normal. If you incident at your light ray on the normal, then it will go through the medium without any refraction. So for refraction, it's important that ray is not passing through normal. It's not passing through normally. If you pass this ray normally, then there won't be any change in the path of light. Okay, now that we have two laws of refraction, one is Snell's law, and another first law says these three rays, incident ray, normal, and the refracted ray. all these three rays lies in the same plane. Means if you are taking your incident ray and normal ray in the plane of the board, then refracted ray will also be in the plane of the board. Refracted ray will not come out of the plane of board. It will be in the plane of board. This is the laws of refraction. First law of refraction. So during refraction, what happens? Speed changes, wavelength changes, frequency does not change, color does not change because color depends upon frequency. Laws of refraction, first ray, incident, refracted, and normal all lie in the same plane as the first law. The second law says this is angle of incidence and this is angle of refraction. If you take ratio of sine of angle of incidence and sine of angle of refraction, which means you take sine I and you take sine I, this ratio will always remain constant. Always this ratio will remain constant. If you change I, then R will change in a way that sine I by sine R will remain constant. This is the Snell's law. The ratio of sine of angle of incidence and sine of angle of refraction does not change for a pair of medium. It does not depend upon the value of I and R. No matter what value of I you take, the value of R will adjust it in a way that sine I by sine R will remain constant. That's Snell's law. So first law says incident ray, refracted ray, and normal all lie in the same plane. And the second law says the sine I by sine R is equal to constant. And the value of this constant is equal to the relative refractive index. It's refractive index of medium 2 divided by refractive index of medium 1. And we know how to relate refractive index with the speed. N2 by N1 is V1 by V2, which is lambda 1 by lambda 2. This is Snell's law, second law of refraction. The ratio of sine I and sine R will change when you change the medium. If not changing the medium, then this ratio will remain constant. And this ratio will be equal to the relative refractive index of refracted medium with respect to the incident. Is it clear up to this Snell's law, everyone?
Yes, sir.
Ishma,
Yes, sir.
Nabil, Minashi,
Yes, sir.
Yes.
just note it down. We'll see.
So the ratio will change if we are like changing the medium.
Yes, if you change the medium, then this thing will change.
So how?
Because this ratio will depends upon the refractive index, right? If you're changing the medium, that means you're changing the refractive index. So how this ratio will change depends how you are changing the refractive index. If you are increasing the refractive index, then your R will increase. If you're decreasing the refractive index, then your R. So it depends upon the refractive index of the medium.
So,
Mhm.
sir, if the medium remains the same, so the Snell's law, it will be like constant, sine I by sine R.
Medium remains the same. That means medium 1 and medium 2 both are same. Both are the same medium. What are you saying? Medium remains the same means. Arpit?
No, so you said na, like if it will.
I'm saying
what are the
medium remains.
conditions?
Yes, I'm saying medium remains the same means. Let's say this is water, and this is glass. You are not changing this medium. So whatever the value of I is here, the value of R will adjust itself in a way that sine I by sine R will be equal to refractive index of glass and refractive index of water. So the ratio will remain constant. Sine I by sine R will remain constant.
Oh, okay, sir.
I can explain it again if you have any doubt in first or in second law. Umar, Vishma, Anshika, Miraj.
So you can just summarize if you want to.
Which one, first law or just second law? Or both?
Here for first law.
First law. See, the first law simply says if in refraction, the all three rays, like incident ray, refracted ray, and the normal ray, all three rays lie in the same plane. Same plane means if you drop your incident ray in the plane of your paper and the plane of your copy, if you draw your incident ray in the plane of your copy, then your normal ray will also lie in the plane of your copy, and your refracted ray will also lie in the plane of your copy. Your refracted ray will not come out of the plane of your copy. It won't happen like if I'm taking my incident ray in the plane of my laptop. My refracted ray will never come out of the plane of my laptop. Refracted ray will also remain in the same plane in which my incident ray was. So if you draw some incident ray in your plane of your copy, then your refracted ray and normal ray will also be in the same plane. You understand plane, right, Umar?
Yes, sir.
The copy on which you're writing is one plane.
Yes.
So all lines that you are drawing is in one plane. So your incident ray, normal and refracted will all be in that plane. It will not come out of the plane of your copy. That's the first. The incident media and the refracted medium. The N1 is the incident medium, the medium in which you have incident ray. And N2 is the second media, where you have refracted ray. Krishna, doubts?
Oh, sir.
Okay, let's do the second part. See, applying Snell's law in this form, like sin I by sin r is n2 by n1, can sometimes be very confusing. Like you can get confused when to take n2 by n1 and when to take n1 by n2. So to avoid any confusion, what you can do is you should apply Snell's law in product form. How we apply Snell's law in product form? See this medium 1. The refractive index in medium 1 is n1. And in this medium, the angle is I. So just take n1 and multiply it with sin I. Take n1, multiply it with sin I. When you take second medium, it's refractive index in n2. Angle here is r. You can take n2 into sin r. So when you take sin I by sin r, it comes out to be n2 by. So when you apply in this form, you can make mistakes. So just avoid any confusion. I would prefer if you apply in product form, n1 into sin I is n2 into sin r. Please note it down.
We can either remember the formula. This is not necessary.
That's not necessary. But it's better if you write in product form. You will realize why I'm saying this when we come to slabs having multiple refractive. This will save some time.
Answer.
Okay, then there are some facts like if rays travel from rarer to denser medium, then they bends towards the normal. But if they travel from denser to rarer medium, then it bends away from the normal. Rare to denser, rare medium means medium having smaller value of refractive index. Denser medium means medium having greater value of refractive. So if it travels from rarer to denser, this is the rarer medium, this is the denser medium. See, if there is no refraction, then light should travel in this direction, the direction of blue light. But due to refraction, it bends. This is the angle of refraction. So this is known as bending towards the north. And if you take when the refraction is from denser to rarer, then see, this is the refracted rays bending away from the north. If there is no refraction, then the direction of ray is that of this blue line, blue ray. It bends away from the normal. This is the refraction. Note it down. And if you want to compare this R and I, see, when it bends towards the normal, then this R is less than I. When it points away from the normal, then look at this diagram. This R angle is greater than I. Angle of refraction is greater than angle of incidence if it bends away from the normal. If it is bending towards the normal, then refraction is less than incidence. The angle of refraction is less than. Note it down. Anshika, which one have higher refractive index, rarer or the denser medium?
Sir, which one has?
Higher value of refractive index, the rarer or the denser medium?
Sir, the denser.
Denser. Note it. Anji, can I scroll?
Sir, done.
So everyone have written up to here? Anshika,
One
Ishma,
minute.
or
Done, sir.
no, do this question. Just solve the first part of the question and write your answer in chat room. First solve the first part. Right answer of part 1.
So we will get the exact value in degrees of sine r. Oh, sorry, r.
Decreased.
Sir, in degrees. The first part.
No, no, just get the answer in sine inverse something. That's it. Sine inverse or something. No, it's not correct. No, the value of sine cannot be greater than 1. No? You're getting sine inverse something which is greater than 1. It's wrong. No, Arpit, it's wrong. Sine, the value of sine can never exceed 1. Nabil is correct. So Noha and Arpit, you both are making the mistake. You are taking wrong values of N1 and N2. That's why I was saying that use Snell's law in product form. Nabil is correct. What about the rest? Hishma, Minashi, Noha, Yashika. Krishna, your answers? Akshay? That's the first part I'm saying. No one is able to solve instead of a Nabil. Yashika, are you solving it?
So I'm doing it again.
Uneeb, your answer?
Yes, sir.
Sir, I'm solving.
Akshay, again, you're making some mistake in just multiplication. Otherwise, it's good. Yes, Ali, it's correct. Good. Apply Snell's law in product form. No need to convert it in decimal. You can keep your answer in fractions also. So you'll get sine inverse of something. Yes, Akshay, now you're right. And it would be better if you can apply this in the product form. Huh? Otherwise, we'll get confused in N1 and N2. Yes, Uneeb, it's correct. It's right answer. Yes, Yashika, it's correct. Ishma, Minashi, Krishna. Yes, Arpit, it's right now. Anshika. Second part, if you want, you can skip the same type of question, but first part is important. So for all those who are not able to solve the first part. Okay, Nabil. See, the question says, in the first medium, where refractive index is 3 by 2, angle of incidence is 30 degrees. You're supposed to calculate angle of refraction in a medium where refractive index is 4 by 3. So we'll be applying Snell's law in the product form only. Na? If you apply Snell's law in product form, then you will make less mistakes. See, this is N1 multiplied by sine 30 is equal to N2 multiplied by sine R. How much is N1? N1 is 3 by 2. How much is sine 30? It's half. How much is N2? It's 4 by 3 multiplied by sine R. So you have 3 by 4 is equal to 4 by 3 into sine R. So you can say that sine R is, if you cross multiply them, this is 3 by 4 into 3 by 4, right? So sine R is, it's 9 by 16. And you can say that your R is sine inverse 9 by 16. This is the angle of refraction. Note it down. Second part would be your homework. I will share the answer.
Can you show the second part, sir? I haven't written.
I'm just coming to it. Just first. Okay, Alia. Okay, note down the second part. Those who have not. Second part would be homework. I'm sharing the answer also.
So can you show the question?
This is the question. Second part. Okay. This is the solution of the first part. This is the second part, answer of second part. It's 4 by 9. You can take the screenshot. This would be homework. You can take this as a hint. This is the answer of the second part, 4 by 9.
So can you also show the first part?
Mhm. Yes, can I scroll it? No? Umar?
Yes, sir.
After this, next we have types of refraction. So we can divide the topics of refraction into two categories. One is refraction through a plane surface, and another is refraction through a curved surface. Plane surface means the transparent surface is plane. It's like a plane. So there's no curvature here. And the curved surface will include lenses and everything. So the first topic in plane surface is refraction through combination of media. So to explain combination of media, I have to draw this ray diagram.
So
Compound
this
plates.
is a glass slab.
No, this is combination of multiple glass. So let's say you have a plate which consists of a system which consists of many plates.
पिछले वाले क्वेश्चन का सेकंड पार्ट
That's your homework, Anil. Yeah, answer it. 4 by 9. So this is first plate. Then you have another plate. So you have two different mediums. Huh? Medium number 1. Here, refractive index is N1. Medium number 2. Refractive index is N3. Sorry. N1. Medium number 2, refractive index is N2. Medium number 3, refractive index is N3. Then again, it's medium number 1. So Siri will come back to the same. So this is the incident ray. This is the normal. And this is the angle of incidence eye. So when the light ray travel from first medium to another, let's say it's traveling from rarer to denser, it will bend towards the normal. Or it's denser to rarer. Let's draw this diagram. This is your angle of refraction arc. Now, when it travels from the second medium to the third medium, Krishna, can you guess the value of this angle? What will be the value of this angle through simple geometry?
Sir, R1 only.
R1 only. This normal and this normal are parallel. This is the transversal, so this will be R1 also. So for this surface separating medium 2 and medium 3, this is the angle of incidence. The ray gets refracted. And you can say this one is the angle of refraction, R2. Now, the ray is again coming out of it. This angle here is also R2. This is angle of incidence, and this is the angle of emergence. So for the first surface, angle of incidence is I, angle of refraction is R1. Second surface, angle of incidence is R1, angle of refraction is R2. Third surface, angle of incidence is R2, angle of refraction is sine. Now let's apply Snell's law for all the surfaces. For this particular surface, sine I into N1, which is equal to sine R1 into N2. Here it's N1 and angle is I. So you have N1 into sine I. In this medium, refractive index is N2, angle is R1. So sine R into N2. So sine I by sine R1 is N2 N. Similarly, if I apply Snell's law over this surface, for this surface, angle of incidence is R1, angle of refraction is R2. Here, angle is R1, refractive index is N2, so sine R1 into N2. Here, refractive index is N3, angle is R2, so sine R2 into N3. So here you get sine R1 by sine R2 is N3 by N2. Similarly, for so N3 to N1. Here it's sine R2 multiplied by N3. Here it's sine E multiplied by N1. You write sine R2 by sine E is N1 by N3. Now what you can do is you have to multiply all these three equations and tell me the relation between I and E to it. Draw the ray diagram, write all these equations and then multiply them. When you write all these equations, just multiply equation 1, equation 2, equation 3 and get the value. I need relation between I and E. What's the relation between angle of incidence and angle of emergence?
So,
Hmm.
so in this case, the incident ray and emergent ray, so aren't they like on the same line? So after refracting through different medias.
Yes, if you multiply these equations, then you will get this result that I will be equal to E. Then you can say yes, I and E will be parallel. We'll come to that result. Just first multiply the equation and see what result are you getting. Then we'll do that discussion. Yes, Alia. Except I and E. So except sin I and sin E. Did you get any final result on multiplying these three equations? Yes, Nabil. Did you get any result on multiplying these three equations?
Sir, I got one.
1. And the 1 is on the right hand side. And what is here on the left hand side?
Sin I by sin V.
Yeah, sin I by sin E. Minashi, not 0. It should be 1. It should be 1. So when you multiply them, everything gets cancelled out. You'll get this thing, sin I by sin E is equal to 1. Or you can say that I is equal to angle of incidence is equal to angle of
Lateral displacement.
lateral displacement. We'll calculate it when we do a single medium, just glass slab. In this compound plate, we don't calculate lateral displacement. What we calculate is we just calculate that incident emergent are equal. Yes, everyone have written up to here? I is equal to E.
Yes, sir.
So this means if incident and emergent medium are same, here medium 1 and the emergent medium are the same medium, then angle of incidence will be equal to angle of emergence. It's always true. No matter how many mediums are in between. Even if you have 10 mediums and your incident medium and the emergent medium are same, then your angle of incidence will be equal to angle of emergence. And if this surface 1 is parallel to the last surface, if these two surfaces are parallel, then you can say then this incident ray and this emergent ray will also be parallel. If this phase is parallel to this phase, then only incident and emergent ray will be parallel. If they are not parallel, then I and E may be equal, but incident and emergent rays will not be parallel. Here, the phases are parallel, so I is equal to E, and you can say incident and emergent medium are same. That incident ray is parallel to emergent. Parallel. Incident and emergent rays are parallel. No, you don't. Okay, so we'll stop here. The next class we'll try to finish this.
So can you repeat the parallel point again?
I'm saying if incident and emergent mediums are equal, then I will always be equal to E. But if this incident surface and this emergent surfaces are parallel, then only incident ray and emergent ray will be parallel to each other. This surface one and the last surface. If they are parallel, then only incident ray and emergent ray will be parallel to each other. But if they are not
Okay,
parallel,
sir.
like if one surface is like this and another surface like this, they are not parallel. I will be equal to E, but the rays will not be parallel. Oh, we'll stop here. We'll continue this thing in the next class. Sure. Bye. Thank you. If you have
Thank you,
doubts,
sir.
I'm free. We can discuss it.
Thank you, sir.
Sir, I didn't understand the last topic. Can you repeat it again? This
Which-
derivation.
The whole derivation.
Yes.
Okay. So just give me one second.